Hey guys, it's Mr. Gibson, and in this video I'm going to show you guys how you can evaluate limits by direct substitution. So this looks like a lot of notes, but it's really just a pretty easy idea here. The idea really comes from down here, which we'll get to in a second, but here's some basic limits that you have. So as we have B and C. So B is just a number, C is just a number, X approaches B, X approaches C, and we just have a number. It's just going to, the limit's just going to equal that number. If it approaches a linear function, X, it's just going to equal C. If it's an exponential function, it's going to, as X approaches C, it's just going to be C raised to whatever that exponent is. And similarly, if we have a rational exponent, or a radical function as x, oops, got that wrong there, so I can fix it and actually show you guys the nth root of x, it'll be the nth root of c. Okay, that'll be the limit. Okay, x approaches c. Then there's a few rules here. So if I've got two limits, if I know the two limits, and limit as x approaches c of f of x equals L, so number L, and the limit of x approaches c of g of x equals some number k, then we have a few rules that we can generalize here. So if you've got a number, a scalar, multiplied by the function, it's just going to be that same scalar times the limit. Okay. If you've got the sum of two, if you're finding the limit of the sum of two functions, well, it's just going to be the sum or the difference of this, of the two limits. Product the same way. If you have a limit of a product of two functions, it's just going to be the limit will just be the product of two functions limits. Okay. Quotient same way here. Limit of f of x over limit of g of x. Just making a special note that k can't equal 0. You should never have a 0 in the denominator. And then the power. There's a little power property here where if you find the limit of f of x as x approaches c is L, then it's just L raised to the n if you have the whole limit raised to the n. Okay? But here's the basic idea. The idea is this. If you have a limit of x approaches c of some sort of function, some polynomial or just any function, okay, all you've got to do is plug in this number for x. That's what this is telling you. This right here is just a rational function. So it's p of x over q of x. All it's saying is you're going to plug in c on the top and c on the bottom. Okay? So this is where, this should be p of c doesn't equal 0. Okay? Actually, no, q of c won't equal 0. Anyway, so basically the basic idea and why it's called direct substitution is you're going to plug in whatever the limit is approaching just directly into the function. All right? So let's see a few examples. You'll see how easy this is. All right, first one is we have this power rule here. So all I'm going to do is plug in 4 for x squared, x squared becomes 4 squared, and 4 squared of course is 16. So the limit of, as x approaches 4 of x squared is 16. And substitute here. What's the limit of x approaches 4 of 5x? Well, I'm just going to plug in 4 for x, and that'll equal 20. Okay? Here's a little about this rational thing here. So limit of x approaches pi of tangent of x over x. So we'll just kind of split these into two. So we'll have tangent of pi over pi. Okay? And if I remember right, tangent of pi is 0 over x, so it's going to be 0 over pi, so it's going to equal 0. Here, let's plug in, we have limit of x approaches 9 of the square root of x. Well, let's plug in 9 for x, so it's square root of 9, well, that equals 3. Here's a product one right here, so we're going to have the limits of x approaches pi of x times the limit of x approaches pi of cosine x. Okay, well, we're just going to plug in pi for x and pi for cosine x. So pi for x, cosine of pi. Well, the cosine of pi is -1. So it's going to be pi times -1. Well, that's just negative pi. Okay. So a little more of a complicated one there. This, same thing, got that power, just going to leave it alone for right now. We're just going to plug in 3 for x. So 3 plus 4 squared, 3 plus 4 is 7, so 7 squared is 49. So we've evaluated all of those limits. Now here's a couple that might be a little more complicated. I've got a rational and a radical, a rational and a polynomial, my bad, okay? So, but again, we're just using the same principle. Let's go ahead and plug in -1 for x. So I'll have -1 squared plus -1 minus 6. -1 squared is 1 plus -1 minus 6. These will be 0, so it equals -6. So the limit of x approaches -1 of x squared plus x minus 6 equals -6. This one, you kind of split it into 2. All right. We'll plug in -1 for the top and -1 for the bottom. So -1 for the top will just be -1 squared plus -1 minus 6, which we already know this one. That's going to equal -6. All right, on the bottom, I'm going to plug in -1 plus 3. Okay, -1 plus 3 is 2. So it's -6 over 2. If you simplify it, it'll be -3. Okay. So those were some examples of how to evaluate limits using direct substitution. Again, you just plug in whatever the value the limit is approaching into the function, and it will give you the output. Okay. Thanks for watching, and do the associated assignment.